Hi everybody, I'm David Malloway. I'm an engineering educator and I'm about to show you a draft of a video project where I made an attempt starting a couple of months back to crack open a few of the organization methods in this lab and how to compile tools and workspaces strategically for mechatronics. And I really wasn't pleased with it. For each section, if you watch this video, you're going to notice that if you think like me, you'll see, okay, there's a better way to consolidate this information. There's a better way to describe the methodology behind it, and kind of each section might deserve its own video and its own planning. But this is an effort that's stacked on top of the efforts of actually just building a robotics prototyping space. And so I'm going to do the uncomfortable thing and just share the draft and treat this, once again, I've probably said this for a few videos now, I'll treat this as a feedback loop where we know there are some meaningful and valuable pieces of information that I'm sharing. We know that many of the audience can kind of interpret what I've struggled to say clearly into the very meaningful sort of communication, but it is simply just not where it needs to be yet. So I'll share it just because the whole purpose of openlab, qr.net/openlab project, and the purpose of our publications on methods of 3D printing under Scalable Robotics, and the purpose of all this open source stuff is to create transparency and to flush out the everything that falls short of best practices and get enough feedback from all these brilliant people around the world that are kind enough to give us their attention and new ideas. By the way, I read loads and loads of comments, and some of them each require a miniature deep dive to reintegrate. Okay, this I can identify your inputs are better than the practice that we've got going on, and now to integrate that into a system cohesively where everything else in the electronics and software and space creation and powering stuff, it all has to work together. So over time, this should all improve the scripting and the videography, and the key points that I'm sharing all should improve, and it should be able to help even like academic research spaces and industry startups of small business people. I want to eliminate the things that are not high value and then just retain the best. So thanks so much for your inputs on the Discord and inside of these videos. Whenever you share a remark that includes an improvement potentially, then when you include the hyperlink, that there are many, many more readers that find that and that can enhance their own workflows based on your information. So be specific when you can. And thanks so much for your attention. Here's another process for organization on tools used very, very often. Let's call it pairing. If the tool A is used all of the time, and every time I get out this, I wind up going to look for the scissors. I want to trim the labels the way I want, not just using that snip function. Then I need these scissors. So I glued the magnets here so that this sits nice and flush along the side, and the number of times I have used them together is so high that I guarantee I've saved the time already just in 1 month of going to collect these scissors and return them back to where they belong. The number of occasions times that time saved is absolutely helpful. And then also the number of occasions where I was making a sloppy label that hung off the side and then eventually it peels off. Now, labels don't hang off the side of anything because I will always use the scissors instead of just saying, oh, I don't want to go fetch them. So quality goes up for all of those occasions where I was too lazy to use the scissors, and time taken goes down for all of the occasions where I was going to implement the quality. Here's another quick suggestion. I keep my paper towels in this thing that I made. I made it because I can't purchase this anywhere the way I want it. And this will be the 10th time that I vacuumed off the top of this cover because it's full of debris. And if I did not have this lid, that means all of that debris would be inside of my paper towels that I'm using to actually clean things precisely and very well. The debris is not acceptable. So I never probably would have even known that source of contamination when I'm trying to clean something off. Imagine the phone screens, the lengths they go to clean off a phone screen and invent gadgets that they offer you to get every last particle of dust off before you lay something down. Well, we have loads of activities in the lab where that needs to happen. We need that level of precision, no dust. And so here, this is a free design idea and a free ingredients to make it. How do I work with this? I slice all these rolls in half, and then I pull out the cardboard, grab the center of it, and then it's ready to dispense itself. And then in here, I have 2 different types of paper towels, 2 holes in the top, and then I select the one that I need. For toughness, the blue ones are better. And then I'll feed that through, and then they're just quick, easy access. Oh, here's another thing. Okay, so I need to clean up quickly. There's 5 or 10 cleanups per day, and this is an important one. So we don't want to sit down and open up every single bin to put away the screw. And so we just have like a few categories. I work with M6 a lot, so I dropped one in there. This is quarter 20. So when I have to put just one thing away, I can either throw it in the trash, put it in a pile where I can't find it, or I think you guys get the idea. This saves me a ton of time. So next time I get out the quarter 20 box, I can easily sift through these few things and just drop them in. If I make a mistake anywhere along here, the whole system is forgiving towards that. Another example of things undergoing trial is the whole mounting system itself. After the wall was painted, we're getting ready to put these panels back up, and I said, well, last time it was 5 or 6 holes per panel and more. If I need to move any of those, it's going to be more holes in the wall and components and repainting. So what other options do we have? Okay, let's make it modular in the sense that if I just want one, then it'll go on these aluminum racks. I only fasten the aluminum beam onto the wall. And now this gives me the potential to have them sliding. So now I can hang things on the back side. I have about 30 millimeters behind there. I can hang flush things back there. I could add a hinge to it. So we're right now I don't need that, but we built it in such a way that can be modified later. And the effort level to give us those options was not any higher. We didn't add any cost or effort. So in this case, we're just using the metal brackets directly. The welded metal bracket between here and here is just part of the panel, and I didn't build any roller or purchase any rollers. That can be purchased on the day that I want to upgrade, and we don't have to reverse any of the effort to get that upgrade later. Okay, look here, we've got this little piece of silicone wrapped around the metal peg that keeps it from hanging too low and making everything want to slide off the rack. And so I repeated that here and here and here, and I just kept on doing it. And so that's not the automatic solution. This is the second revision of a solution. We do the very minimum amount of effort. So once you set something up and then you detect it has issues, like this one doesn't hang perfectly, but it's good enough that these things don't slide. Like you see, they don't come down. Okay, so the first revision in this example was a piece of wood. I just cut up a little piece of wood and I put 2 little grooves in here, and then I stuck it back there. And I used, it was first we asked, is that even important? And so I just make one of them. I stick it on there. And then there was no glue. It wasn't even bonded. I just stuck it there. It's like, I don't move that often, so maybe it'll just hang there. Okay, and then several months go by. I move these around and it becomes very useful. So I made 3 or 4 of them. and every time I move something, of course, they're dropping on the floor, so I want it bonded, and I added glue. Then I'm realizing, all right, this is approaching, we need standardization on this, and so if I need to make 10 more of these pieces of wood, then it starts to be worthwhile to just have a 3D print. I can design the geometry and print it out. I have as many as I need, print a few extras on the day that I set this wall up. But before I go to do that, then I check, okay, what would this look like? You have, oh boy, these paired hooks, they have a certain spacing. So that means either I need 2 units for that, or I'll have to print a second geometry that has that spacing. And I found another one that has a different spacing. Okay, now there's gonna be 3 versions of a 3D print. That's getting to be a nuisance. Is it worthwhile? And so hold off on 3D printing and we look for another solution. Say, what other options do we have that's less work than making a piece of wood, that's not requiring me to buy whole new sets of pegs. And then so anytime that I'm creating a solution, that is always under trial and potentially going to be replaced with something else that's easier to standardize, easier to equip. I mean, I can ask a 10-year-old to go and outfit these, snip these with scissors. It's safe, it's easy, it's quiet, no sawdust. And so everything, all the solutions are continually dropping down in their effort level, ease, affordability, repeatability. Just got done switching this tube out for another. So this is part of standardize. S number 4 out of the 5S. Another function of the organization and standardization to note is control of the airflow. So I've done many trials in the last 3 years to evaluate how much corrosion takes place on my parts. If these need to be stored for 5 years, then I don't want them to corrode. In some cases, it doesn't matter. In some cases, I need very clean, fine precision. So I happen to know that the gaps, like this gap, it does allow for air exchange, but I can drop a desiccant packet into this capsule. Now, things that are fully enclosed are better for pre-planning than things that are not fully enclosed. If I only accommodated a drawer for this or a way to hang them without an enclosure, then I also cannot control the oxidation. So the factor that fights against that is if we're looking for things that are fully enclosed, that may be very expensive compared with the alternative options. So we need something that has a very reasonable cost to reproduce, because if I want to supply a different type of metal that oxidizes a lot, I need to be able to solve that. This one I could quickly wrap around with tape, or I could, I have a method already to control the air and the oxidation to whatever degree I need to. There's a tendency for some of the younger professionals, some of the younger engineers to see equipment like this and kind of view it as a cheap thing. So in their mind, we could come up with a nicer solution if we had a bigger budget, but that is not the case. It is the optimal selection for what's available right now, given our Toyota values. Okay, this falls under standardizing. So S number 4 out of 5S, and that is when we select this capsule, we find it, we decide if we want to standardize it and produce more of them, then we're asking, if we purchase this container, can we also purchase it again in 1 year? Does it come in sizes so that if we enjoy this function, that we can find other products of the same function that come in longer sizes or larger diameters? And so what makes this the right choice for us in this case is that those answers are yes, we can find more options for this. We can find them in different countries. And so our system of organizing using this box, this tube capsule, is not broken given all other variables changing. So we have some shortcomings that are evident. This is a pretty cheaply made solution. If you tug on this vertically without twisting it, it will pop free. If you hang too much mass, then something may break on that. But we don't see another standard option, a higher quality version of this existing yet. And I would bet that it will come out in a couple of years. They're going to be making more. This outline may help with some of the young folks. So the option that appears to be cheap is actually the option where, first of all, we can buy more than we need, so there's replacements ready immediately if it breaks. And this countermeasures the issue of the quality is less than desired. And then also you can find, because it's more, the cheap option is more standard, you can find many suppliers for that. You don't get stuck in a place where you can't order some. The expensive version, you're going to tend to just buy exactly the number that you need, and then you have a harder time repeating that if you expand the lab, if you have something that breaks. So I'm telling you that Jeff Bezos would make the same decision that we're making right here, because scalability is such a priority. The next problem is these will get too full. There's too much stuff on my panel where I'm used to finding things. So that could drop down how quickly we can retrieve and find what we need. There really shouldn't be more than like 3 hanging, because then I'm having to remove things and set them down somewhere in order to get at the back one. So then we add in a data system. So I removed the front panels out of these, put them all on their own card, and then I just put number 9. So number 9 will be up here somewhere. I want to know what's the specifications, where did I order it, how much was it, or what size is this thing that I can't tell the size of it. Then I'm just going to open up that panel and see number 9 and look at the back of it or whatever. And then next step will be to get this scanned. Most of these are already scanned, but there will just be a QR code on this whole thing so I can scroll through the data instead of having to open up physically. Here's a tip about cords that maybe I never mentioned it before. So every cord can get folded the same way. You leave a little slack between the appliance and the cord. You just slide that until you have the end. Now you have 2 lengths that are equal. Fold those. Now you have 4 lengths that are equal. And then you could fold it again, and now I have something too long that's too floppy. So the very last fold is either 2, if you like that length, or 3. And you can adjust the length. See, on the very first try, I said, oh, that's I haven't got them equal. And so without ever losing grip, you can match it up. So now they're all neat. You don't take up too much space in the drawer. And I use my bicycle tire rubber bands. If you want to store one together with this, you can cut one extra thick and say, all right, now I want a stronger rubber band for this bulky cord. And then you can put it up next to the tool in the drawer. Or if you're storing it for a long time, then I'll go ahead and grab another rubber band and hold that up next to there. It just saves time when I go to retrieve this. So I'll drop this guy into the drawer, and I know there's supposed to be space for 3 big tools here. 1, 2, 3, and I'm just leaving that space. I don't actually have a designated label for everything, but it's just becomes obvious. So if someone else is to put the next tool back in there, it's pretty clear. And then we don't label every single tool in the drawer. We label the most common one that's getting retrieved, or the largest one that sort of puts the image in your mind of what that drawer looks like. So this has some stuff for fire and some stuff for the grinders, and then, sorry, the grinders themselves, as well as the wheels, the accessories that go with them. And then these, that's temporary. It overflowed from drill bits. It didn't fit in there. And so that's sort of my suggestion is everything will not always fit. Okay, and so your temporary solution would be put it in the next nearest place. And so at least if we don't have a new place for those drill bits, then at least it's very close and it's easy to find when you go to search. Or like me, you'll just remember that because these are tall racks. We're sure that we're not going to find them in this short drawer. Here's a quick lesson I learned about surfaces. Okay, so blonde is the color for most of these wood tops, and you can see it's shining. This one's been all scratched up, but still, I mean, operates great, and it's still very easy to wipe clean. So you're looking about 1 year of wear and tear on that. And the reason this wood plus epoxy just this way has been chosen is because it can all be cleaned and repaired partially or fully at any time at low cost. So there was a period when I was choosing what sort of worktops we'll need, and there are factory worktops that are harder or stronger, like steel, or some of those composite desks that you have in actual, like at the university and so forth. They're a little bit stronger than this, but if they do get a scratch, which they will, or if you do gouge it with a tool, which I have done, you can't repair it. You don't have the supplies to match the process that they did in the factory. So in this case, this is like a 10-minute repair, 20 minutes, 10 minutes to sand it down with 220 grit. No need for a second type of grit. And then a quick pour of a very thin layer of the two-part epoxy. Once you have a process for this, the epoxy is insanely affordable. Okay, at the first stage, this is a lab that began after I've already built some labs at the university and other places. So I thought I want one surface that's going to be pretty expensive, that's very hard and flat, but good looking for cleanliness and doing projects that need neatness. And what we got at the end was even better than that. So these toolbox surfaces, I just wanted them rugged enough that I could place tools on there or do things on them as needed, but they were not expected to look good. So I got 2x4s, and this was the cheapest way to get it a tough surface. Then we looked at the grain. I said, well, what can I do to just generally coat it quickly and cheaply? And so I used a stain of a dark color, and the idea was to hide the variations in color. So when debris and items fall down onto it, like, you know, bits of screws, etc., then they don't get lost, and I can find, I don't have something blending in due to the distracting color variations, and I don't have, if this was smooth enough, then I wouldn't lose parts. But it was much better on the blonde surface when I worked in the subsequent months. So light color, just natural wood color was fine. This is just a tad darker than the wood right when you buy it from the store. There's no stain, it's just the way it comes out after the coating. So the other requirement was that it's repairable cheaply and easily with supplies in the lab. You'll see a dowel there. There's a couple of dowels in this one. So if it got a gouge or a gnash that's messing up the surface, then I'll just plug it with a dowel. And if also if I created some fastener like these ones, I added a handle and I changed where I put that, then everything just gets plugged. It's pine on pine or oak dowels in pine. Easy, cheap, repeatable. Those dowels come in very long 3-foot sticks. Then I ran a trial where I said, well, what if I finish up one? I had just built a new work surface, and I said, well, since it looks so nice, let me try coating it and see how tough this surface is. That surface is marvelous, even tougher than wood. The strength of the wood just below, a very thin layer of this, is sufficient to prevent most gouges. Like, you know, I can drop this or heavy things on it, no problem at all. But then there were just more and more benefits. So it's fully sandable. If you sand this and then you're transitioning into the wood, so you have it partly removed and partly still there, then you apply another layer of that on top of it. it blends completely in. It bonds completely. There's not any delamination between an old layer of this epoxy and a new layer. So that means it is repairable to any degree that you wish. And so I got this pocket showed up while I was pouring this one. It's not a big deal. This tabletop looks way nicer than it was supposed to. This was a very rapid and not quite careless job, but just a job to get it sufficiently waterproof. If I spill stuff on there, it doesn't seep into the wood. That was all I was going for. But you can achieve this in just one coat, and that's not, if you've tried this before, that's actually a surprise. They recommend, if you call Super Clear, they recommend 2 coats. I could do another video talking about that stuff, but the key takeaway is works great, repairable, and spots like that can be fixed anytime that I wish. It's not going to get worse while I wait. And in the meantime, right, it was the cost. So we're looking at $80 thereabout for this 2-gallon set. Maybe it's over 100, so very high price tag and worrisome. But I wound up with, so there's this much left. I've already done the top and bottom of this surface as well as sides. I poured it all on some miscellaneous projects, like some layer here to just see if I could make a flat surface, setting this vertically, and it does. The first layer just sinks in, second layer could make it all flat. And that table and that table and that table, both sides of all these tables, and so there's still plenty left. It's all a matter of having a good process to apply it. That's wonderful. Power distribution is another element that ought to be carefully thought out, and I haven't mentioned it before. So all of the power outlets on the back wall, they're on one circuit. And so the heaviest tool, usually I'll drive my planning by the heaviest tool. At the time, maybe I didn't have this tool, but I had these ones. So you don't need to know everything that you're going to use. You just need to know what is the biggest power demand ordinarily. Consider the last 6 months. So each of these cords are on one circuit breaker back at the breaker panel. Okay, power distribution is another matter regarding electrical power that supplies each of the stations or the large tools. We have one essentially on the back wall, and we have one on this wall. It's scattered in a couple of other locations, but 3D printers are sort of on their own. They're on a dedicated circuit that doesn't have only power going to the printers, but it is not going to any other large machines. And so the large gray rail on the back wall is the circuit for these printers. The next power circuit that was deliberately planned is for this station. That's the starting point. So we measure all of our large tools. This is how you might plan this. Instead of, it's maybe unreasonable to know your plan at the very start before you're doing every action. So we measure the most high power consuming tools. So this one was 15 amps. It's by far the heaviest power draw, current draw. We're only on, I think, a 20 amp breaker, but you can purchase a few modified. You see the gray outlets, those are rated for 20 amps, whereas most of these are only rated for 15. I've never had any problem whatsoever using the 15 amp breakers for any tool, including this one. But in any case, this one was dedicated because we know there will frequently be a high power machine on this end. And then because of that, that's why we included the 20 amp outlet. That these are only $1 each, whereas these ones are maybe $10. It's a big difference. To unlatch the garage door, it's simply a matter of unplugging these from the wall, so everything is still changeable. We have slack hung up so that if there's a snag or a tug down here, we're not tugging to put a torsion on this connector and cause something to get bent, or just a hazard in general. Okay, back to the planning. So we measure the highest current tool, and then we ask what else will be running in the same moment as the saw, because that would be our highest current condition of the lab being worked. So for example, I would not be running that saw and this drill press at the same time. So the next heaviest thing is vacuum, one of the vacuums. Those have also both been measured, and we found that, okay, running those two at the same time is actually at the very peak. It's much more than 20 amps, because this one is maybe over 10 amps, but just running a few tests on separately and other circuits, I never saw a problem in performance of these two working together, and I never saw a problem in the circuit breaker tripping or other electrical hazards. But the overall lesson was, we will treat this entire wall or the whole circuit, even other small things that are plugged in, as the one that's dedicated for this station. And then if we add tools or add other processes to this space, we will choose not to overload that circuit, and large machines will go on to the next circuit over. Okay, this table might help simplify the complications of dedicating circuits in the lab and planning the methods together with that. So we're just doing this based on the circuits can be however they are, but we'll make a special case for constraint situations. First constraint is there's a heavy machine that pulls current near the maximum of that breaker. The action to do in the lab setup is dedicate a breaker for that machine. And then the subsequent method in the lab, or the rule for operating in the lab after that breaker is dedicated, is there are no continuous loads already on that circuit, such that I'm wanting to turn on this workstation, I don't have to be concerned about the peak being any higher than the peak of this machine, the vacuum plus the saw. Okay, and continuous load would be something like the lights or ventilation in the lab itself, something that is going to be on regardless of a project, and that shouldn't be turned off, or if there's a very small light that's going to be always on that breaker, then we just verify that the combination of this load and my heavy power tool load is acceptable. Next constraint, sensitive and continuous devices. So something like a 3D printer, it is not a heavy power load, but it is sensitive, such that if it gets interrupted, there's a problem. So the action for that is to dedicate a circuit for that set of continuous machines. And then the implication is, yes, you can still plug other items into this circuit, but you're either going to do heavy items when this is not running, or you're going to not add any heavy items to that circuit. And then the last bit is if you have a constraint of, I need flexibility. The example is this table here. So we have power outlets all around the table. This work surface is a place where we want to be able to, on the fly, set up any project that we want to, including maybe there's a heavy machine that day that needs to be used. So I'm needing flexibility, the maximum flexibility. Okay, so we dedicate a circuit for the table, and then the constraint is during ordinary work, we don't have any required continuous load. So there's not going to be like an air conditioner plugged into this table, because that would consume half of the amperage available on that circuit. And so if you already have 3 circuits, maybe 3 plus 1, then you don't have to do any wiring. If however many of these constraints that you have, that's how many minimal dedicated circuits you should build. So in the case of those heavy tools over here, then we don't have any catastrophe take place if there is a problem with overloading that circuit or if the breaker trips. Whereas on the 3D printers, if the breaker trips or if there's some other issue, if we even just need to power down the circuit to work on something, then we'll have an interruption of ongoing process, and that will cause a problem. So we take the circuit for the printers and we put minimal number of other devices on there. And then we have a circuit for a more variable situation. So this tabletop with its outlets included is essentially on its own, where the rule is essentially load this up with as much power things as we want. At a special moments, there may be a heavy tool operating on there, but in general, we could leave devices charging or laptops plugged in or things that are non-sensitive to interruption, but we do want them to have power all the time. Looking at mobility for a moment. As you can see, some things are fairly well fixed and some things move around, like this vise is easy to pick up. We've actually added silicone base to that steel so it can be set down anywhere quickly, almost carelessly, and it works out for us. Now, mobility is a thing that often we have it decided for us by the manufacturer of the tool. And sometimes we don't even think outside of the typical box. So let's say bench vise. The word bench means it's usually going to be fixed to a bench. It doesn't move. And why is that? So in most cases, the time that you want to clamp something down is the time that you want everything to be as fixed as possible. No vibrating if I'm needing to file an item. Okay, but we look at our specific work and we ask, do we need our work process to be fixed just like that tool is offering, or is it better for it to be portable? And the answer is there's both realities. Here's how you can look at it. If we make the fixed selection for a tool or a supply, then it's going to have some drawbacks and some advantages. And then you just have to ask yourself, what process are we doing in this location that adds up to be more advantages for fixed, so we want the fixed option. We want to, and then you're going to be dedicating space for it, etc. So you can mentally go through the scenario where your workshop has its work done and then decide, all right, we have this vise, we've made it to be mobile, and the one drawback is the stability, but it has a lot of its own mass, and so the stability is a very small drawback, and there's much more advantages to have it mobile. So for example, the most common, we ask ourselves, what's the most common use when this tool is being used? It looks something like this. Small part in the vise, oriented how we want, and using a Dremel or a file, etc., to do some shaping. Okay, in that scenario, Dremel is not exerting a ton of force. Stability is required, but we don't need that very heavy stability of the bench, the actual massive bench top. And so that drives the decision of, okay, we'll go ahead and configure this tool or this work setup to be mobile. Now, if we do sanding, large amounts of powder or dust flying, then we can just bring it outdoors or to the ventilated space. All right, the second most common use case for this vise looks something like this. We need to draw a precise hole, cut a precise hole, and that's the reason that we have this angle with the indicator for fixturing. Okay, then can we have this fixed the way we want in that situation? Well, yes, because we purchased the one that has slots, and now all it takes is a few fasteners to have this rigidly fixed to our workstation. So we come back to the scenarios with drawbacks and advantages, and we just capture all these so we can have all the advantages whenever we want them. And that's kind of doubling the effectiveness or the number of situations where the task is served by the tool. So right here, you're looking at the opposite situation. The tool typically comes in in a way that's portable. So there's a simple 2-prong plug on the back, just goes into any outlet, and then we can bring this wherever we need to do the heating. But this is the heat gun that we use for more often than any other task. It's shrinking down heat shrink on a wire. When we're building wiring, then we're usually here doing the soldering as well. And so we, in order to gain some advantage, we say, okay, well, let's go ahead and invest in setting up a fixture where this can live. Now, we get this one advantage of having it fixed, and that advantage is the hands-free adjustable positioning, right? And so that gains us an advantage, and we lose the portability because now it's actually wired into the station. That's a separate goodie. So since it's wired into the station, or the reason it's wired in rather than just plugged in is because now we have this quick switch. So now that's an extra additional hand. Usually the helping hand gets us, this fixture gets us one free hand because it's held in the right orientation. And then this lets us use our knee to hold things with both hands and have it quickly turned on and off. That's all just based on use case. So we said the use case is we usually just need this for 5 seconds at a time. Okay, 5 seconds at a time, we'll do this switch, and it's wonderful. I love having this thing.